Okay, very good afternoon. So now we will continue with the next point, that is B plus tree. I hope all of you have understood the B tree. Now next part is the B plus tree. So what is the difference between the B tree and B plus tree? So that part we will discuss. First we'll discuss the what is mean by B plus tree. Minimize. कुठले नेटवर्क कॉलेज मोबाईल आहे now screen is visible to all, so I have shared the PPT as well. So is it visible?
Yes sir, visible.
Yes, sir.
Yeah. So B plus tree, so is the data structure, right? And it is also used for balancing the multi-way search tree, so which represent the sorted data, right? Now here also we are performing the insertion, retrieval of the data, removing the records, right? And here also we are identifying the key values, or we are displaying the key values also. Now what is the actual change here? So first point we need to consider, that is the root node has at least, so same rules. So just I will revise all the rules. So first rule is the root node has at least 2 children. At least 2 children, right? So and almost young children. So same rule. So whatever the rule we are using for the B tree, same rules we are using for the B plus also, right? After that, the next is the second rule we are using, that is the except the root node, except root node. So all of you give attention. So in the previous session also, so except root node. So whatever the internal you are considering, so for that internal node, so at least, so m by 2 children is required, and almost young children is required. And regarding the key also same, except the root node, each node has at least m minus 1 divided by 2 keys and almost m minus 1 keys. And the node with the children v1, v2 up to vm, and storing the key values k1, k2 up to km minus 1. Now here key in the subtree of the v1s are less than or equal to the key one, right? So same rule, whatever the rule we have used for the B tree, same rule we will use here for the B plus tree also. After that, keys in the subtree, so of vi are between the ki of minus 1, I minus 1 and k of I, right? And keys in the subtree of vm are greater than km minus 1. Now here the difference is, so whatever the leap node we are considering, so diagram is visible to all?
Yes sir.
Yes, sir.
Okay. Now all leap node must be at same level. Now in the B tree, so whatever the leap node we are considering, so that we are not considering at the same level, but here all the leap nodes we have to consider at the same level, right? And there should not be an empty subtree above the level of the leap node, right? And all the keys, now whatever the keys we have considered, now in the B tree, so we are maintaining the key at root as well as in the leap node also, right? Or in the child node also. But here all the keys are maintained at the leaves only, or at the leap node only. Okay. So all of you remember. So what is the first difference in the B tree? Suppose now everyone is aware. So we have drawn the B tree. So 10. So simple B tree I will draw here. Suppose 10, 20. Is it visible to all? Camera. So you can look in the camera, right? 20, right? Now here at this side, so you are maintaining the keys. So which is less than the 10, right? Suppose 5, 6, 7 like this. Right, after that, here you are maintaining the keys, so which is greater than for 12, and here is the 14 like this. And here you are maintaining the key like 21, 23, 25, right? So these are the keys. Now, how many keys are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? 10 keys are there. And how many nodes are there? 1, 2, 3, 4 nodes are there. Right? But value of 10. So where you have maintained? 10 value where you have maintained? At root node only. Right? And 5, 6, 7. So you have maintained at leaf node. Right? After that, 12, 14, 21, 23, and 25. So these values you have maintained at leaves only, right? And 10 and 20 you have maintained at root only. But in B plus tree, so what we are doing? So we are maintaining all these values at leaves only, right? We are maintaining all these values at leaves. Now, how to maintain this 10 and 20 in the leaves? So for that purpose, so here I will use 10, say 1, 6, and suppose same tree I want to convert it into the P plus tree. So what will be the change? So first try to understand the change. So what I have done, so 10, so I have used in root also, but this key I have maintained at leaf level, right? After that, so 12, 14, and here, here, 12, 14. So what I have written? 12, 12, 14, and next is the 20, right? So where I have maintained 20? At the leaf node, right? And after that, suppose here is the another value. So what we have considered? Can I consider 24 and 2? Okay. Now here, so all the values of the key where we have maintained at leaves only or at leaf node. Now again, so all the keys are maintained in the leaves and the keys are replicated in the leaf node to define the path for locating individual axes, right? Now here again, so we have defined the path between these two nodes. Now this node will connect with the second node and this node will connect with the third, like linked list, right? And after that, so here in the PDF you can observe, so all the leaves are linked together to provide a sequential path for traversing the key in the tree. And after that, so record of all the keys here I have written. So record, so what is R1, record R17, record R36, record R42, record 53, record 56, 65, 31, 83, so 96. So in the diagram you can observe. So all these records I have maintained at leaves only, right? But in B tree, where we are maintaining the key value? At the respective node, right? So intermediate node or in the root node also. But here in the B plus tree, so we are maintaining the record of all the keys at leaves only. And after that, all the leaf node or leaf nodes are interconnected with the each others. So this is the main difference between the B tree and B plus tree. Now in the above B plus tree, so whatever the B plus tree here is shown, so in that, so the records are stored at the label leaf node only, right? And all the keys are replicated in the non-leaf nodes to define the paths for the locations or locating individual records, right? So what is the benefit of using the B plus tree as compared with the B tree? So what will be the benefit? Now suppose I want to search any element. So where I will search? In B tree, what we are doing? So am I audible to all? Hello, hello.
Yes, sir. Audible.
Okay. Now I want to search the element. So where you will search in a B tree? So from where you need to start traversing? Root. First we'll check at root level, right? After that intermediate node, and after that you can check leaf node, right? So sometimes you will get the key value at root level or at intermediate level or at leaf node, right? But here in B plus tree, so where you will search if you want to search any key value? Is it necessary to search from the root?
No, sir.
So directly you can search it by considering the leaf
Leaf
node,
node.
right? So this is the benefit of B plus tree. So what will be the benefit? So you are able to search the element very rapidly or very fast. So this is the benefit. The B plus tree provide the rapid sequential access and also provide the rapid random access also. And in B plus tree, the leaves are linked together to provide a sequential path for the traveling the keys in the trees, right? So this is the benefit of using the B plus tree. Now we'll see the examples. So how we are inserting the elements in the B plus tree and everything. Just to. Now example, is it visible to all?
Yes, sir.
Okay, now we'll see directly examples. So create a B plus tree. So which is having order for you by using the following key values. Now when you are constructing any keys, B plus tree. So we are following the whatever the rules we have followed or we have used for the B tree, same rules we will use for the B plus tree also, right? Now here the how many key values are given? So just to read out key values. 40, 109, 12. How many are there? 12. 11. 40, 109. After that, 15, 189, 120, 190, 130, 360, 4, 5, 110, and 210. Right? And here, order. So, what is the order? Order is order order is 5. Right. Now the root node contain same rules we will use here. Root node contain at least 2 children and at most 5 children, right? Except the root node. Except the root node, each internal node. So all of you remember. So I think you have asked the questions. Except root node. Root node la ek key असेल तरी चालेल, right? So you can consider if single key is there for the root node, so that will be considerable. So at the time of splitting, so root node will be with the single key only. Now here the next rule, except the root node, each internal node has at most 5 divided by 2. Now here equal to 3. So which value we are considering? Floor value or cell value? Floor value we need to consider. So 5 by 2 is equal to 3 we are considering, and at most 5 children you need to consider. And each node has at least how many keys? 2 keys. Now here minimum how many children for the internal node? 3. Right. And minimum keys 2 and max 5. 5 and here
4.
4.
right. Now this is the first rule we have followed. Now in B plus tree, all keys are maintained in the leaves only. This is the change in the B and B plus tree. And keys are replicated in non-leaf nodes to define the path for locality of individual records, or to access or to retrieve the record. So we need to maintain the path, or we are linking all these leaf nodes by using the arrows. Now the leaves are linked together to provide a sequential path for traversing purpose. Now insert 40. Now first element will insert. So insert 40. So how it is inserted? So 40 is inserted like this. So 40 inserted, right? So B plus T after inserting 40. Now after that, next element is 109. So where to insert? After 40. 109 I have inserted here. After that, next element 15. So where to insert 15?
Before 40.
For 40.
Before
40. Next, insert 189. Where to insert 189? After 109.
10.
After 109. 189 is inserted. Next, now insert 120. Now what we need to do here? Splitting. Now, if we insert 120 in the node, so then overflow condition will occur, right? Now we need to calculate the median. So 120 you want to insert. So 120. Now where it will be inserted? After
109.
1099. So here it will be inserted. Now what will be the median here?
109.
109. Now all of you observe the next construction of the tree after insertion of, here I write insert 120. Right. So after insertion of 120, so 109, so we'll consider as a root, and here, so first 15 as it is at left side, 40 as it is, and here, so 109 we are maintaining at leaf level also, right? But in B tree we are not considering at leaf level. So this is the first change. So 109. After that, and again, so this is connecting with the next node by using the link, right? So what is the next?
120.
20. 189.
180. Now this is the first step after insertion of 120. So B tree after insertion of 120. Now insert 190. So where to insert 190?
After 189.
After 189.
After
189.
189. 190. Okay. I can insert it easily. B plus tree after inserting 190. Now next, insert 130.
Before 120.
Here, 130.
It is not visible properly.
Not visible. Now is it visible?
Yes, sir. Yes, sir.
Now visible.
15, 40, 109, 120, 130, 189, and 190. Right. Now insert 160. Now where to insert 160? So what we need to do?
Split.
So after 130, so you are able to insert, right? So what you need to do here, you need to apply the splitting, right? But where this 160 is added, so can I erase this one? Now you can tell me the nodes. Next, what is the next node here? 120. Next node, that's it.
130.
30.
130.
130. And here, which node you are?
160.
160.
Now, where to maintain the 160? Here,
180.
after 160, sorry, after 130, 160 is maintained in the leaf node. Next,
189.
189.
189,
190.
90.
190.
190. That's it. Okay. 190. So, after that, next 45. Insert 45.
After 40.
After 40. 45. Here 40. And here is the 50. Right. Next element 110. So where to add 110?
Before 120.
120.
So before 120. One 110. Next element 210. Where to add 210?
After 190.
190.
Which will be added easily here after
190.
210. 210 is visible, Tom?
Yes, sir.
Okay. Now here, so which can be easily inserted in the B plus tree. Now, after inserting 210 of order 5, so in this way, so we can insert the any number of keys element in a B plus tree, satisfying the conditions of the B plus tree. So here, in this way, we have completed the construction of B plus tree. Now here, so what is the change or what is the difference between the B tree and B plus tree? What is the change? So all the key values we have maintained at which level? Leaf level in B plus tree. So at which level we have maintained?
Leaf level.
Leaf levels, right? And all the leaf nodes are connected. Right? Connected with each other. So because of this connection, so what will be the benefit? So randomly you can access any of the elements in a B plus tree. So this is the change, and this much modification you have done in a B tree. Right? So is there any difficulty in the B plus tree or in B tree? अवघड आहेत का सोपे आहे ते ट्री? Offline student is saying it's very easy. So what about online?
Easy आहे, sir.
Easy,
आहे
sir.
ना? थांबू का थांबू शिकवतो?
Hello, sir.
Huh?
Hello, sir.
Yes.
Why this 109 and 160 is repeated?
109 and 160 is repeated. So, what is the answer? So question is why 109 and 160 is repeated? In the B plus tree, we are maintaining all the keys at root leaf level only. Leaf level आपण सगळे keys maintain करतोय, त्यामुळे आपण ह्या repeat केले. वरती कुठंच राहणार नाही ह्या keys. वर जेवढ्या repeat होणार आहेत, याच्यावरती root असू द्या किंवा इथं असू द्या, ते सगळे keys काय असणार आहेत, ह्या शेवटी आपल्याला मिळणार आहेत. At the end. And when you want to search any keys, so directly we are searching at leaf level. Right? So this is the main reason. Or this is the modification. So we have done in B plus tree. So we are maintaining all the keys at leaf level. ज्या सगळ्या keys आहेत त्या सगळ्या आपण leaf level ला maintain करतो. And here we are connecting the one node with the another node. This node is connected with this. Got it?
Yes, sir, got it.
Now deleting a record in B plus tree. Now next operation is the delete operation. Now here you can see, is it visible, Tom?
Yes, sir.
Let me hide. Now delete 120, 45 and 189 from the given tree of order 5. Right. So here the same tree we will consider. Now step 1. Suppose if you want to delete 120. So how to delete? How to delete the 120? Already you know the delete operations related with the B tree. Now I am expecting the few things from your side. काय करणार इथं? The key value. So where you are searching? So I am expecting the answer from your side. आता मला 120 delete करायचं आहे. So where you will search? In leaf node or in root node?
Leaf node, sir.
Leaf node.
Directly कुठे search करावं लागेल आपल्याला?
Leaf node.
वरती root ला किंवा intermediate node ला search करायची गरज आहे का?
No, sir.
No, sir.
Now this is the advantage of B plus tree. So in B tree, so what you are doing? So you need to search from
Node.
root node to the leaf node,
Leaf node.
right? So the key value 120 is compared with the key value in the block B1. So here block B1 means, so first leaf node, right? And the key value 120 is, what is the block 109? So what is the highest value of block B1? So 120 is less than 109. Condition is false. So then it will not be visited to the left subtree. Left subtree मधला सगळ्यात highest value कोणती आहे? 109. First we'll compare with the 109, right? So if the value is greater than 109, means in which block you will search? In which block you will search?
Seconds.
In second, right? So you can see a condition 109. Now 120 is greater than or equal to and less than or equal to 160. Means these, if this condition is true, then in which subtree it will visit or we will traverse?
Seconds.
Second, right? So traverse the B3 subtree because 120 is in the between 109 and 160. So this is the B1, B2 and B3, right? So in the B3, so we'll search. And in the node B3, right, the key element 120 is compared with the key element, and the key element 120 is present in the node B3, and B3 is the leaf node. Then delete the key element from the above node also. right? So here 120 is deleted and B plus tree of order 5 after deleting the 120. So directly we have deleted the 120. Screen fluctuate हो जाएगी कितना problem. Now next delete 45. Now what you will do? So in which block you will search?
First block.
Leap node first block. त्याला काय म्हणणार B2 म्हणणार. So first block हा root चा B1 झाला, हा B2, B3 and B4. So in the B2, so we'll check what is the highest element in the B2?
109.
109. We'll compare with the previous deleted which element you want to delete. 45 is less than 109. Condition is true.
True.
So we'll search in the first block only of leap node. Leap nodes are first block, right? So here element is available. 45. Yes, right. So you can observe here first diagram. 45 is available. So directly you can delete and here you will get the result. Now here the delete operation as compared with the B tree is easy or complicated? Which operation, in which tree the delete operation or insertion operation is easy?
B plus.
In
plus.
B plus tree, right? And searching operation, in which tree it is
Plus.
very easy? In
B
B plus or in B two?
Plus.
B plus.
Right? Now next, so delete here, just 1 minute. Now here B plus tree concept is completed. This is the last page. Now is there any doubt up to this? Any question? So today we have completed the multi-way search tree. After that, balanced the multi-way search tree, B tree and B plus tree. Now we have completed. Any questions related with the B plus tree? Now we'll see the difference. So just we'll see the difference between the B tree and B plus tree. So what is the first difference? A B tree is organizational structure, right, for information storage and retrieval in the form of a tree. Just a minute.